Let's take a look and see if we can figure out how that formula works. So assume two players, Glinda and Jack, are playing tennis. The probability that Glinda wins a given point, the probability Glinda wins a point, is 0.6. What are the ways to get 3 points where Jack has 2 of the points? What is the probability for each arrangement? First thing I need to know is what probabilities do I have? Probability for Glinda winning a serve is 0.6. That means the probability for Jack is going to be the complement 1 minus 0.6, which means 0.4 for Jack. Then what are the ways to get 3 points where Jack has 2 of the points? Well, Jack could win the first point, the second point, and then Glinda could win the third. Or Jack could win the first, Glinda could win the second, Jack could win the third. Or Glinda could win the first, Jack the second, and the third. When I have events that are one following the other, I need to multiply the probabilities because I want this whole set, this whole arrangement, Jack, Jack, Glinda, like that. And so to do that, I just multiply the probabilities for each of the individual events. Jack has a probability of 0.4, so it's going to be 0.4 times 0.4 for the two Jacks, and then times 0.6 for Glinda. And if I multiply that, I get 0.096. And then I can do the other two. Jack is 0.4 times 0.6 times 0.4. And it looks like I'm just multiplying the same three proportion or probabilities, so I can just write down the same result. If you want to double check it on the calculator, please do. Glinda, Jack, Jack, so this time it's 0.6 times 0.4 times 0.4, and again that will come out to 0.096. So it looks like any of these three orderings for Jack getting 2 points, Glinda getting 1 point, the result is going to be 0.096. So let's take a look at the same concept. What's the probability that after 3 points, the score will be 30-15 in favor of Jack, and use the formula. So we want to check out the formula and see what we get. So this was the probability of the 3 points, 3 different ways, all the 3 combinations that would end up with Jack having 2 and Glinda having 1. So now we want to look at the probability of the score being 30-15, so that's 2 to 1. Remember, the 30 means 2 serves 1, and the 15 means 1 serve 1. So we can put those in like this. This is Jack, and this is Glinda, and that means that this 2 is my N, and the 1 is my M. So the formula, remember, we like to write out the formula first before plugging values into it, just so that we can see what we have. But I'm going to write just a little bit of a modified formula, and that is I'm going to put the probability for Jack raised to the N times the probability for Glinda raised to the M times N plus M factorial over N factorial M factorial. So I've written it, instead of putting probability of A, probability of B, I've put in Jack and Glinda just to help me out a little bit. But otherwise, that's my original formula. And now I'd like to start plugging in values. So the probability for Jack, remember, was up here, and it's 0.4. So it's going to be 0.4 to the N, and my N is 2 in this case. I want to know when Jack wins 2 points. Probability for Glinda, that's up here, is 0.6. And M is going to be the number of points I think Glinda will win, and that's a 1. And then I add the 2 points, so it'll be 2 plus 1 factorial all over 2 factorial times 1 factorial. There are a lot of ways I can work this. I think what I will do is just rewrite this 2 plus 1 as a 3 factorial, and then I can also work this one out, 2 factorial And we know 2 factorial is really just 2 times 1, right? Okay, so we can work it on the calculator and just get the 2, or we can know that's just a 2. 1 factorial just means 1. It just does, because it's 1 times everything smaller until you get to 1. There's only 1. So this whole denominator comes to a 2. And then I can look at the 3 factorial. I can write it out as 3 times 2 times 1. And then I know that that 2 in there is going to cancel with the 2 down below. Or I can just work these out on the calculator. So I'm going to show you that just so that you have that option as well. 0.4 to the, so I'm going to use my caret key, to the second times 0.6 to the first, which isn't going to change its value at all, but I could put that in if I'm not sure. I can just put it in, to the first times 3 factorial equals 0.576. Remember, I still have to divide by 2, 0.288. So I'm wondering if I added all 3 of these together, what I would get. So 0.096 times 3, or I could add them 3 times. I get that same probability. So 0.288. So it's the probability of any of those 3. The union, remember, would be the sum of all the events. So the union of them is 0.288, and that's what this probability formula is giving me. It's saying any one of those, any one of these arrangements could happen, and that's what this formula is giving us.